So the next, I think it's not really enlightened or not as fast and like Eichel did, but you want to introduce some of your, let's say, packages or utility packages you developed while working on your finite state machine program.
So is it.
It's yours.
Thank you. As I expounded before, finite state machines are my thing, and I showed you a bit of the DCL, and here I have the documentation for that. Along with what I showed you, I have the documentation, and the DCL, for example, the domain-specific language, is documented here. And it's, as you can see, it's quite a bit stuff. And I did use the way Richard Hipp is using his railway diagrams to make all this grammar visible. And while developing the thing I showed you before lunch, I developed several packages. Let's begin with a simple one, or let's begin with XVAR. XVAR is the expandage of variables, the percentage thing that you have seen, and that is a separate package that you can import, and there is the documentation for the patterns it matches and how it will expand them, and there are examples in there. And this feature of the percentage signs that you can put in some strings and get them expanded is available in a package that I will make these packages available to you in the coming weeks, next week or the weeks after that. There's another package that I wrote for myself, another wrapper for dict. And as many people do that are getting sick of writing dict all the time, I have introduced abbreviations for that. And I'll have you look in the code, and that is the dict implementation. And there is a for each loop where I have the dict subcommands, and I might make an interp alias to that, so I do not have to write it out.
I just want to say interp alias for such a thing is probably not the most efficient solution. Unfortunately, Tcl does not really have a namespace alias or something, but there exists some trick, some six-liner procedure to create a namespace alias, and that's way more efficient because it gets byte compiled, whereas interp alias does not get byte compiled.
Oh, that's a very good hint. We have to talk about it later, and then I change it. The interesting part is I have interp alias for the thing that are already in the dict, and all the things that are in the dict start with a lowercase letter. And I have expanded this. I have some more functions that I thought I need, and they always have a capital letter after the D. So you can immediately see from the command whether it is an addition I made or whether it is just a wrapper to the existing functions. Well, I do not want to go through all this stuff. What I try to show you is the CR merge. CR merge stands for conflict resolution merge. And the thing is, I have two dictionaries I want to merge. And if the same key is in both dictionaries, that is something I would call a conflict, because I could now go and say, for example, one is stronger than the other and overrides in the resulting dictionary, or and to say how to resolve the conflict, there is a conflict resolving dictionary in front. And actually, the thing is, I do not have to write very much in this conflict resolving dictionary, because there's a mechanism that goes to the default case. I have just a default case there where I say in the default case merge, or in the default case override, replace it is called here. The merge is the following: dictionaries can be hierarchical. So the value of a key can be another dictionary, and there again the same things apply. So usually I have very short conflict resolving dictionaries, even if I have rather deep dictionaries that I merge, because it finally goes in the most cases back to the default case, which says, for example, default is merge. And I used that quite a lot. And I think it is so useful that it should be available to you too. And if you play around with it, you can give me feedback on that. That's just one of the additions I made to the dict wrapper. And there are more, and as I said before, you can see whether the second letter is a capital letter, whether it's an addition, or whether it is just a wrapper around what we already had. Then there is, let's go to USUM. USUM is a utility for denominated values. When I say I have a step in a finite state machine, I want to say how much it costs. And the cost should not be just a value. If it is a value like 11 milliseconds or something like that, then this is usually not true on all machines. On one machine it is more expensive, on another it is less expensive, and so on. Usually each step consists of several operations that are carried out underneath, and every operation has its own costs. So the cost of a step is actually an aggregate. It is a sum of some denominated values. And this sum I can then evaluate in different contexts. The context may be machine 1, or with 4 cores, or with 2 cores, or whatever. So the final evaluation is done with some context, and this USUM does the following. You can give aggregates as costs to some transition, or to something in a graph, and it does the partial evaluation of what it can evaluate at that point, and delays everything to the final evaluation point that you can do later with different contexts. So you can evaluate the same thing in different contexts and see how it performs. And therefore, I will be able to do the costs in my finite state machine DSL as sums of aggregates, and then I evaluate that in different contexts and can say, in this context, it is fast enough or not. To give you an example, there are examples down there. I made several things. Here is an example with feet and inch or whatever. It's artificial, actually. It is nothing. It is just to show how such a aggregate might look like. It could be something like that. I even put in something like Celsius versus Fahrenheit. This is difficult because it's not a linear transformation. It is an affine function between Celsius and Fahrenheit, and even that I can handle with this package and can partially evaluated. And there's a difference to all the packages that are already out there in EuroTcl. In EuroTcl, this is these packages with Fahrenheit and Celsius and so on, they are pre-programmed. Here it is not. It is actually an environment where I can use, can implement any linear or nonlinear function as a special subclass of the EuroTcl classes I have implemented. And with this specialization, I can evaluate all these aggregates. So it's a very open and very minimalistic approach to have symbolic aggregates as cost values on whatever you might need it for. Here is an example where I evaluated with different context information. Another package I developed and that I find really useful is LDIF. LDIF compares lists. For I have very often found that I'd like to know whether two lists are disjoint. If I view them as a set, if I say the list is a set of elements, and I would like to know, is this disjoint or not? Or where do they overlap? And I can do this with more than two lists simultaneously. And actually, I do it like that. I assign a bit value to every element and get thus integers. Actually, I usually say, okay, the list should be shorter than 64 elements. Maybe it even works with more. I have I have to do a bit more. But my lists usually are shorter than 64 elements, so for me, this is no restriction. And then I get integers where I can do all the bit operation stuff with that. And to get the basic, here is about the idea and how I do it. The mental picture I have is like in a dartboard. If you have a dartboard like that one, that's mine, you can see every field is comprised of lots of sisal fibers, or you have the darts that are sticking in it or whatever. Those are the elements. And then you have the segments. They are going from the outside to the inside, like some triangle. And then you have the rings. And the colors you see here are already the intersections or part of the intersections. There are more possibilities, and that's the mental picture. Actually, if you have just the circles and the triangles, you somehow want to know where are the intersections and have different names with them. And in my if then else structures, I wanted to say if I'm there in one of these fields, which is an intersection of several, I go to some other place. And this ability to calculate partitions, a spectrum, and many things more is captured in this LDIF package that I will also make available on the internet, on the EuroTcl wiki probably. And I use it very often, for example, that I say I have scripts that make up my environment, and I want to say I want to see the stuff for this project and that project and that project, and then I have in my code, if the chosen selection intersects with what I do here, then I do it. And so I find it really useful, and it's fairly efficient too. Actually, I think it is so useful that one might think about making it at some point a re-implementation in C, so that we have the quickest possible execution for this kind of thing. Once it is on the internet, you can play around with it and can then later on vote on whether it is worth putting more effort into this or not. I have a few other packages, but that would go too far now. I leave it at these 4 that I have shown you now, and hope you enjoyed it. Thank you.
One question, Florian. Would these packages be a good, let's say, part of EuroTcl, for example?
Yeah, probably. But they need a little more work. So,
or maybe EuroTcl for a start test. And there's also EuroTcl
Pardon? So putting it in some part of the EuroTcl would be a good thing to do. Finally, so maybe we have it at first somewhere where you can get it. The documentation are these HTML pages I have here, and once we have some feedback what should be improved, like I just heard before, then we can have it somewhere where it is more easily accessible. Okay.
Any further questions, anybody? So thanks again.